Good morning to you all. So in today's day school, we are going to discuss object-oriented programming, testing, and deployment. With the deployment, we will be looking at some other phases in the software lifecycle process. That part we would be just giving an introduction to this project management, etc. So to start with, we will do object-oriented programming part first, and that would be done by Mr. Neil Herat. Afterwards, I will be doing the testing and quality assurance part. Thank you. And over to you, Mr. Neil, you can start.
Okay, thank you. Can you see my introduction to object-oriented programming screen?
Yes, sir.
Okay, how about my voice? It's okay, or?
Yes, sir, it's clear.
Okay. Now, introduction to object-oriented programming. I will cover these topics. Function-oriented programming concept, that is one paradigm of the programming. Then object-oriented concept. Objects, attributes, methods, parts, class, information hiding, inheritance, abstract classes, information hiding, constructor, getter, and setter, aggregation, composition, and polymorphism. I will use Java programs to explain these abstract classes, object-oriented methods. I will explain function-oriented programming by the C program, because C is not actually supporting to the object-oriented programming. Java, Python, like those programs are supporting to the object-oriented. C++ also supporting. Function-oriented programming concept. Here, this is a C program including functions and the variables. This red box includes variables. Here, the variables are num1 and num2. Variable type, data type is integer. I think you have done already C programming. This is main function. There are two functions, calc avg and calc sum. Passing parameters here are int num1, num2. There are two variables passing. Here there are two variables passing and return this sum and average. These are functions. Here we call functions like this. Calc, KVG, num1 and num2. This is a concept of function-oriented programming concept. Then after that, this some programs cannot do by the function-oriented concept. Therefore, object-oriented concept emerged. The advantages of this one is these function objects programmed by the languages can be reused. And we can modify them inside them and without any modification to the functions. Because in function programming, we always change functions. Here we change objects. So there are so many advantages than in function programming. There are sometimes disadvantages also. Here the objects we call tangible and intangible. Here there are two objects, person and car. Intangible objects such as courses, like those things are intangible. These are real world objects and we convert them to the programming objects in object oriented concept. Here there is a relationship between these objects. Person belongs to a car, like a person drive a car, like that. So there is a relationship. Here object, this is an object. This object has there are three things: attributes, behavior, and parts. Attributes are title, name, address, like that. The object is person. And behavior is walk, run, eat, and jump, like that. There will be many behaviors like that. Parts are legs, arms, head. These parts become another object. Here attributes, person, attributes, leg. This object belongs to another objects like leg, arms, head. When we consider leg, it is also an object. It also has attributes and methods. Methods also like operation and behavior. When we programming, it called methods. Operations and methods. Here, these are operations, and when we write programming, we call it as methods. The class. Actually, earlier I explained objects, but the group of objects are called class. Here, Amal, Kamal, and Neela. There are three objects here. All these objects belong to one class, person. A group of persons called class. That is, say, car. Now, Mazda, like those things, there are several types of cars, and that cars belongs to the car class. And this person has attributes, behavior, and parts. Then parts also become another objects. The interesting of this object-oriented is one thing is encapsulation, that is information hiding. Consider these attributes in Nicena. This class is person. Attributes are NIC number, name, age, address, date of birth, like that. And the type of this data attribute is integer. Type of data is string, like that. Here minus sign attributes minus mean private private. This private mean we can access only within this class. If you want to access from outside of this person, we have to write another functions, not methods. Here get details. Methods uh, to get to access these attributes. If we didn't write any uh, methods in the person class to access these attributes from the outside, we can't access. Here the minus sign say when we graphically represent these classes, this minus sign means it is private. They are private. If we type plus sign, they become public. We can access from the outside. Attributes, data type, methods. This plus sign means this method we can write public and private methods also. If we create methods publicly, we put a plus sign. These are graphically representation of these classes. When you programming, there is another method to program. This arrow shows relationship between person and staff. Staff is also person. Student is also a person. So person become abstract classes. That is just name and all the actions taken by student and staff. So this is when it become in inheritance, staff and student belongs to the person class. In inheritance, when it goes to up, it becomes generalized. When it goes to the down, it becomes specialized. Because in a person class, student is specialized. Specialized means it has a separate general attributes and also special attributes. Registration number. Student has a NIC name and age. Both staff and student has NIC number, name and age also like those things. But student has a special thing, registration number. But staff doesn't have. Staff have staff ID. And staff has salary code, department like that. Student has program code. That is separate, two separate attributes, especially for students and staff. So get details. These are operations. This minus sign mean private. plus sign means public. Inheritance, as earlier I explained, this is inheritance. This is abstract class. These are relationships here. Relationship with the without color. This arrow sign is without color. We can consider earlier classes and objects by Java program. This is the class. Person is the class. Person class. It is public. Person abstract class becomes public, and we type it as abstract. Here, abstract, public, class, person. Person. This is the class name, and these are attributes. And this when we type here private, all these attributes become hidden within the class. Private can access only inside this class. The class name person. And this within this program, there's it creates another person class called person. It is public. That is okay. Don't worry. It you will not clearly understand this sentence or this command. It prepares a new object for use. Public person within the private class. It creates another new object for use. Setter. Setter is other objects can write data through this setter. Private void set NIC. If you want to this NIC, here this is NIC number. If you want to access this NIC number, we can access through this, only through this method. In function-oriented programming, we call this type of things as function, but here we call it as methods. Another method is get NIC. No, it is getter. It is this is setter. This is getter. We can write data through this method. We can read NIC through this setup method. Here you can see input parameters. Here you can see when we read it, it only return. Here private can access only inside the class. Constructor, it prepares new object. Setter and getter. Here aggregation. Aggregation means objects can exist separately. This staff and department, the relationship between person and staff is inheritance, because staff is a person. This is a mean if there are two relationship types, is and has. Is a relationship is staff is a person. So they become inheritance. This aggregation means a department has staff, thus has relationship. This object and exists separately. The department and staff are separate, but there is a relationship between staff and department. Uh, we we draw this relationship like this diamond box with white box. Uh, this relationship is not lifetime. Not lifetime means uh, staff is a person. That is, if the one staff member exists, the person is exist. Uh, it is a must. But staff can go resign from the department. That is not a must. That is not lifetime. Department exists, but one staff may be resign and one staff may be recruit. So that is not. It is not a must. So department we include staff class within this department. Here you can see staff, data typing of staff and staff. This is we include it as an array. You don't understand this deeply, but roughly you can understand this aggregation. This is another relationship. Aggregation, how we create in Java program here. This is a staff class we include in the department as a list. Composition. Composition is these are composition relationship. These classes also separate classes, but it is a lifetime because department cannot exist without faculty. Faculty cannot exist without university. So if it is a lifetime if there is a lifetime relation, we call it as a composition. Objects cannot exist separately. Diamond box with black background. It is a lifetime, but here all the attributes are separate, not like staff and person. But here NIC number of the staff same, and the student also has a NIC number. Those are inheritance. This staff and department also and relationship between staff department and faculty department also some like aggregation and composition relationship. It has a relationship. So but these are lifetime. We draw like black within the black background diamond boxes. Polymorphism. Polymorphism means there are two methods here: get details, but same method but different. These are two different, because get details students will be get program code, registration number, NIC, like those things. But within the staff, these get details are different. We get different details: salary code, staff ID, and the same. These are same. We can access here we can access all the details, get details from this the student and person detail, because the students to access the student NIC number, we have to access this person. So that is a inheritance relationship. So we can get details from here, this NIC number also. From get details from here, staff get details, we can get details from here. Here there is a method also, get details also. Within those things, we can access all the details of the staff. That is the end of this object-oriented programming concept. I will hand over to this session to the Professor Udita.
Yes, Ms. Mill, can you enable screen sharing for me?
Okay. Screen sharing. I think Professor Udita, now you can share. Can okay.
What I'm going to discuss today is about testing related to software development. As you know, there are 5 or 6 phases in the software development life cycle. Can one of you tell me what are the life phases in software development life cycle? You can unmute yourself or you can put the answer in the chat. Say if we have like, you can even divide it to 5 or even to 6. What are the phases or stages in the software development life cycle? Starting with requirement, elicitation and analysis. So that is the first stage. What is the next stage? Yes. Can I see your answer quickly? After requirement, elicitation and analysis, what do we do next?
Development.
Not development. So before development, what do we have to do? Now, first one is you're meeting your client and trying to find out the requirement and then analyze it, right? So after requirement analysis, we can't directly come to development. What is there in between?
Testing.
No. Testing should come after development, right? We develop something or implement something where we call programming, and then we do testing. There is an important part to do before developing anything, not only software systems. Say, even if you're going to do say a structural part in a civil engineering project, What do you do after finding the requirements? Before development, what should you do? That is a major part of an engineer's job role. Design, isn't it? After you find the requirements, analyze it, then you have to design your solution. So only after designing, you must embark on developing or programming. If it is a software system, then you do the programming. But if it is a mechanical product or a building or something else, then you start developing or making the product. So in this software system, after developing or in the process of developing, you will have to do this testing to make sure that your program is working properly. So after testing, then only you can deploy it. So in the next presentation, Mr. Neil will tell you how software system, how many ways that software systems can be deployed. Deploying is the way that you are going to install it in your customers or clients' working space. After deployment, what happens? Is there a phase after deployment? Yes. What is the next phase or the stage after deployment? By now, you must have read the book, all these parts. It's a maintenance. Let me see that there's, yes, very good. There's an answer. The maintenance, right? So these are the main stages of a software development life cycle. Now you see from that background where testing comes and where deployment and project management comes. Right. As the content of today's day school, we will be looking at verification and validation, software testing, including system testing, component testing, and test case design. And briefly, we will look at testing strategies, black box testing and white box testing, and how to compute test coverage. So if you take a look at all these contents, other than testing strategies, the other part would be more theoretical. So given focus on testing strategies, because it is from testing strategies that you will get questions in the examinations or the assignments, because you will be given a solution and would be asking about to design some test cases based on these testing strategies. We can look at the software process in this way also. That's the activities, the specification. I hope all of you have done the TMA1. In the TMA1, you were supposed to make the requirement specification. That is defining what the system should do. Next, the design and implementation. Defining the organization of the system and implementing the system. After that, you would have to do this validation. Validation means checking that your software solution does what the customer wants. Please note there are two words, validation and verification, that we use often when we discuss about testing and quality assurance of software systems. The specific meaning that is associated with validation is checking that whether your system does what the customer wants. So the validation will have to be done at the end of the implementation of the product. Otherwise, you will not know whether all the customer's requirements are satisfied. But validation can be done even from early stages. Then it will not be validating the whole system, but partly. Say there are different process models, spiral model, agile model, like that. So without waiting to finish everything, like in the waterfall model, if you are following a method like agile for software development, you may do the validation for chunks of the programs that you do, for different modules that you make. Afterwards, evolution is similar as maintenance, where change in the system happens in response to changing customer needs. Programming and debugging. Programming means translating your design into a program with a programming language. It could be C, Java, or Python, any language. That is where you translate your design into a working program. And at that point, there will be a lot of errors that happens. And as the programmer or the developer, you will have to remove those errors from that program. That we call debugging. So if you look at the diagram in the bottom, it says locate error. And you have to design how to resolve or repair that error. And then you repair the error and retest the program. So this we call the debugging process. When we say programming is a personal activity, it means there is no generic programming process. Say when we give a problem for you to solve, as we do all the time, say for assignments, CATs, and even final papers, we would be giving you a part of a scenario or a problem to solve. And how you solve it is a personal activity, because there will not be a general answer of how you do this problem solution, but there will be set of standard steps that all students would follow. But all your answers may not be similar, that we know. There would be certain steps that everybody should follow, but there will be differences here and there, the way you come to get the answer. Therefore, programmers must carry out some programming testing to discover the faults in the program and remove these faults in the debugging process. So when you finish your programming part, say if you are working in a software company, as the developer, you will be doing the programming part, and then give your software solution to quality assurance team to test. But before that, you must test as much as possible to see that your program works. This software verification and validation is intended to show that the system conforms to its specification and meets the requirements of the customer, right? Not the system. As I said, validation means exactly that the program or the software solution meets the requirements from the customer, and it is usually compared with the specification. Because where does the customer get involved with us? When we are doing the requirement analysis. So after requirement analysis, we make the software requirement specification. And the customer is not involved in the design, programming, testing, or any of these parts until the product is done. And then when we show to the customer, we have to make sure that it conforms to what the customer has said in the specification. And that testing part is also you have to do, or the QA team would do. And there is a specific test called acceptance testing to be done by the customer side, where they would accept the solution given. Only after that acceptance testing. So acceptance testing is really written in the specification, right? So what kind of test the software solution should pass in order to accept it? When we come to the verification, it is the process of evaluating the working products, not the final product of a development phase, to determine whether they meet the specific requirements for that phase. So verification ensures that the right product is designed and it delivers all the functionality to the customer. We can term it as, are we building the product right? That answer to that question is verification. So the evaluation items to find out whether we are building the right product, we have to make plans, the requirement specification, design specification, then the program code and test cases. And these reviews and meetings are also done to evaluate requirements and the specification. Let me explain what reviews and meetings means. After you do the coding, there are many ways to test. One is going through the testing strategies that I'm going to explain later, like black box testing, white box testing, etc. Or the code to be reviewed by another team. So they will just go through your code without actually running it in a computer. That is called review. So at that point, just reading your code, some of the faults can be identified by the outsider. So what happens is, as you know, even when you write a report, you may not, though you try to correct it as much as possible, since you are written it, you may not be able to see any mistakes. Same way, in the program also, there could be obvious mistakes that you may not note. But if somebody else read your code, then that outsider will be seeing your mistakes easily or quickly than you could do, because he's or she is looking at it from the outside. So review means, without running the program, reading the code to make sure that code is perfect or there are no mistakes. Especially, the reviewers can find out in a loop whether the this initial condition is done. If there is a while loop, you know, there must be an initial condition for that index. It has to be made 0, 1, or some number has to be there to initialize. So if that is not there, then the reviewer can easily figure it out. And there could be some variables not defined. So these things the reviewers would easily find out. So afterwards, then you can go to the other testing processes. Validation we discussed earlier also. Why it is coming again is you need to understand the difference. Now, validation is the process of evaluating the software at the end of a specific stage or at the end of the product development. And it is always compared with the business requirement. And you can also say that validation ensures that the functionalities of the intended behavior of the product are there. And the question we ask for validation is, are we building the right product? So the evaluation item would be the actual product or the software. And it also involves actual testing with test cases. So when we go to this next step, the test strategies, you will see these test strategies are used for verification and validation. So this diagram shows testing during the life cycle. As we discussed, the life cycle starts with requirement specification, structural design or the high-level design, detailed design, and coding. So after coding, after coding means after not finishing coding, maybe after writing, say, few modules, you have to start testing. Unit test means it is always correspond to detailed design. The small units or the modules will be tested to make sure that they are working correct. And when it comes to integration and test, that means all these small modules or units are integrated together and tested. And at that time, you will be looking at whether it corresponds to the structural design. And at the end of the product, after making the full software solution, the test you do is called the acceptance test. And the acceptance test corresponds to the requirement specification. So most of the time, the validation will come in this last stage. And the verification means whatever the test done before the last stage. Is that clear?
Yes. Yes.
Right. Thank you. So let us go to testing strategies. So these are the actually testing stages. As I said, unit testing means individual components are tested. Module testing means related collections of these dependent components are tested together. Then subsystem testing. Modules are integrated into subsystem and then tested. Here the focus should be on interface testing. And when we say system testing, that is testing the system as a whole. And we already discussed what is acceptance testing. It is the difference and important is that acceptance testing is done with the customer. And whether the product is accepted or not will depend on this system passing the acceptance testing. So this diagram also shows the testing process that we discussed. So the component testing, integration testing, and user testing when it comes to the end. Right. So up to now, what we discussed is the theory related to testing. From now on, we will discuss two methods, black box testing and white box testing. And this is where you can really design a test case or do something. And based on these principles, you can design test cases for your programs. Black box has a meaning. What do you think black box is? When we why would that be called black box? The answer is here. What is the general meaning when we say a black box? Can anybody say?
We can use that black box without any previous knowledge of testing technique.
Rather than the testing technique, black box means without knowing the internal working of the program, we are doing testing. When we go a little further, you will see what it means. We are not looking at the lines of the program. The program is considered as a black box. We give some input and see whether we get the output that we expect. So that is why we say the tester is oblivious, means tester does not know the system architecture and the tester may not have access to source code even. So here the tester is interacting with the user interface and provide input. Say for example, maybe you have to input your password and the age and some other maybe name or something to get them stored in a database or make a report. So the output would be the report. And the tester here, if it is black box testing, tester will be giving these required inputs. As I said, maybe the password, the age, and the name, and maybe the registration number or something. And then, as the output, what the tester is expecting is the report to come out properly. So if it does, then we say that that module or that program has passed the black box testing. It is also needed. Without that, you will not know whether the program would work, and it is much easier it's easier than the white box testing, giving the inputs and checking whether the output comes properly. So if it doesn't, then definitely you will have to go to the white box testing. There are two types of black box testing that we are going to discuss. One is called boundary value analysis. For example, it says X is valid if X is between minus 1.0 and plus 1.0. And to see whether the program works properly, we must give as input to X as test cases these boundary values. We must give this minus 1.0 and plus 1.0. That is the two boundary values, right? And a small number, very small number, that is lower than the lower boundary, C minus 1.001, and a very small value, which is higher than the other boundary. So with these four test cases, we can see whether X is working properly. When we say we can give an age of somebody as the input, and if you are getting the input as the age as the input, then you have to make sure the user or the people who are using your system do not enter unnecessary values. You can't put, say, 1,000 years as age, right? So when there is a particular variable like age, then you may have to define it into a like what do you call a range, acceptable range, maybe like 1 month to, or even 1 day could be there, but it can't be minus, right? Age cannot be minus, so it should not be minus, and you can define a maximum age, maybe 120 or 130, like that. But that variable should not accept any value more than 130. It can't be 500. It can't be minus 2. If a user input that value, then user must get a error message saying that the user has input a wrong value for this variable. So like that, say you are doing a program to calculate your GPA or average marks of, say, for many courses done in 1 semester or 1 year. And when you are talking about marks, in case the user give a wrong mark in a wrong range, you must, as the programmer, you must be able to catch it and say, this is the wrong input. So if it is, say, a subject mark, and if all your subjects are between 0 to 100, then somebody cannot be putting minus marks, and somebody cannot be putting more than 100 marks. So when entering marks, you can define the minimum, maybe minimum as 0, maximum as 100, and as the other boundary values to check, 1 minus the minimum and 1 plus the maximum. Though I say minus 1 and plus 1, if it is a small integer value like this, then make the other value also a very, no, instead of 1. Now, here it is 1.0. Instead of making it minus 2, make the boundary value very small one, deviating from the boundary, real boundary. Right? Is this clear? What boundary value analysis is?
Yes, madam.
Yeah, right. Right. The next one, there are two types of black box testing that we are discussing. The second one is equivalent partitioning. This is useful if you have two variables and that goes together. For example, the two key inputs for x and y, x is between 1 and 999. Y is between 1 to 5. So if there are two variables, two corresponding variables like this, then you will not be able to do that boundary value analysis. Here, there is another technique we call equivalent partitioning, where we write all the acceptable and unacceptable range of x values and y values in the other side. And then you would get, say, nine components or cohorts where valid or invalid numbers are there. So for example, x should be between 1 and 999. So if x is less than 1, then that value is not acceptable. If x is greater than 999, the whole of right side also not acceptable, right? And y should be 1 to 5. If y is 0, then the first row is not acceptable. The middle row, it means y is more than 0 and less than 6. So that means y is between 1 and 5. So the middle row is acceptable. The total last row, y is greater than 5, is not acceptable from the y variable range. So in that case, you will see only the middle value will be acceptable as within the ranges of both variables. If I repeat it, according to the values of the x variable, the leftmost column and the rightmost column will not be valid. For x, only the middle column is valid. And when we look at the y variable, the topmost and the bottommost rows are not valid. Only the middle row is valid for y variable. So that means only the middle value will be valid or acceptable for both of these variables. So this is what we call equivalent partitioning, and we need, like, there are 9 test, how many? Yeah, 9 test cases that you need to use if you are going to check whether the range is okay for two variables. So we will not go into further in equivalent partitioning. So if you have a basic idea what boundary analysis and what equivalent partitioning is, and if you are given a kind of question like these two variables behave only within these two ranges and give the test cases, then you should be able to draw a diagram like this and give few values. Here in equivalent partition, you must give 9 values. But if it is boundary value analysis, you can give either 4 or even 5 values. So please let me know if you have any question. You can type in chat or unmute yourself and ask. Next, we will move on to white box testing. As I kept saying, in white box testing, as the tester or the developer, you are testing your program knowing the full working of the program. You have access to the source code. So you can see whether it is a loop or whether there are many if conditions, nested if, whether it is a case statement. So all that you will see. While you are doing black box testing, this boundary analysis and the equivalent partitioning, etc., you were not looking at the code. Here you are just giving the input and waiting to see whether the output was coming correctly. Compared to that, in white box testing, you read the code and work with the code itself. So there are many types of white box testing. Let me show the diagram first. For example, you were given an algorithm like this, right? And if an algorithm like this is given, as the tester, you have to make sure the way you coded your program, you are covering all the paths, right? The paths of A, B, D, A, C, B, and maybe B, E, D, or the program that the way you are coded, the program is going through all the paths and all the conditions. There are two conditions here. You have to test when you are testing, but whether this path code true is also accessible, whether the path code false is also accessible. To do this kind of testing, there are several types that have been defined. We call it structural coverage criteria. There are many possible criteria for test coverage. Path testing, that is each path. So that's what I was explaining. Visit each path. For example, if you put A equals 2, B equals 0, and X equals 4, and A equals 1, B equals 1, and X equals 1, see which path you can go. If A is equal to 2, then A is greater than 1. B is 0. Then this condition is true, right? So you have to go through a C path. And when you come here, it asks whether A is equals to or X is greater than 1. That is also true. Then with this test condition, you would go through the path B, E, D. So with the first test case, A equals 2, B equals 0, and X equals 4, you will be going through the path of A, C, B, E, D, like this. And with the other test case, you would be going through this without going through true. It will be false in both conditions. So you would be just traveling A, B, D path. So if you wisely do the test cases or design the test cases, with the minimum number of test cases, you would be able to check whether the full algorithm is being covered. So that is visiting each path. Then there are other types as well. Visit each loop. There are no loops here. If there was a loop, you have to check whether each loop has been tested by the test cases that you have given. And whether each condition, or we say branch testing, we'll do this. Simple path testing means each path without repeated edges. Now, with the first condition, A, C, B, and B, E, D, we are not repeating an edge. edge is this. Now, AC is a one edge. We call it a edge, this line. And CB is another edge. This condition we call a node. Because when we draw this algorithm for testing purposes, we call it not a flow chart, a flow graph. A flow graph consists of nodes and edges. So with the first test case, did you see that each path is tested without repeated edges? So each path is also tested. That is path testing. And simple path means without any repeating edges. Then basis. So independent path testing means a completely linearly independent path. There are no overlaps with the path. And the branch testing means each node. Statement testing also means each node. Now each node is this condition. A equals 1 and B equals 0 is also a node. X equals X divided by A is also a node. The A equals 2 or X greater than 1 is also a node. And X equals X plus 1 is also a node. So there are 4 nodes. Branch testing or the statement testing means each node is covered. So, but with the test cases that you give, all nodes are covered. So there are more test cases. For example, this condition testing. The conditions can be tested in 4 ways. Now, the full program can be tested with only 2 test cases you saw. But say we want to validate that all the conditions work properly, then you can have 4 test cases where first condition is true, the second one is false. Then both true, both false, and maybe the first one false and the second one true. So you can give test cases that would behave or go through the algorithm like that. So if you have an idea of this white box testing, you can decide how many test cases you need and what kind of test can be done. So that is all about testing. So I will stop here. If you have any question, you can ask. Otherwise, I hand over to Mr. Neil to continue with the next. Right, Neil, you can start. I think if there are any questions, you can take.
Thank you, Professor Udita. The next session is deployment and security. Deployment and security. This is 2 topics here. Actually, software deployment is after system analysis, design and development. We have to implement the software. We have to implement in the somewhere practically. Before giving the software to the customer, we release some earlier versions like alpha, beta, to test the system. Most of the time, uh, most companies release freely to test the software and then update it and then release to the customers. Activities in software deployment. Release is not only activity involved in software. Few common used activities are install and activate. Uh, when we buy our software, some softwares are freely you can download, and or some softwares you can download from the internet. Install activation is to give it is actually activation for the license agreement. All the software now in earlier software they don't care about the license, but later software needs a license because some uh, 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 privacy issues. Some software, some others may be theft by others. So to avoid those things, activation needs. Deactivation is opposite of the activation. In software deployment, activities include adapt, update, built-in version tracking. Adapt is software now when you install in the software, but some uh, some of the program may be have some faults and errors also may be there. Those things we can the software company will correct and update as a patches. Update is complete. Now remove that earlier version and install later version. That is the update. Adapt is installing the patches. Update is remove the earlier version and because in the earlier version there will be some patches. Remove the all the available errors and software will be update to the new software version. Automation, some of the new software now earlier version also automatically update and patches updating the patches and installing the new version of. Uninstall it. If you want to uninstall from the computer, the software from the computer, that is there is a way to uninstall the software because when software is installed, program codes will be goes to in several places in the computer. To remove all these software in different places, there is a facility called uninstall. Retirement is ending of the software. Early in any product, there is a decline period and retirement because they will be obsolete. The final stage of testing and releases are pre-alpha, alpha, beta release candidate because alpha and beta are earlier version and for the testing purposes. This is the agile method of testing and release. Uh, After developing the software, uh, actually software developed, software normally software is a big software. Uh, the system designers implement those software by modules. In different modules, there are several modules in a software. So integrators combine all these modules into one and test the software. I think Professor Udita explained about testing. Before the testing, the system should be integrated and then tested. And the development tool is these again add functionalities and extra function. If there is extra functionalities, we have to integrate it. Integrate and testing again and testing again and release it. Release to the customers. But most of the time it release as a alpha. And then feedback review. We check reviews of the customer reviews. Then accept the system deciders decide accept or not. Release to the market. This release is not to the exact market. Uh, this release just release to the customers for feedbacks. This release is released to the market. If it is not acceptable, record and incorporate changes. The software company will record all the problems and uh, change the software and adjust and track, reprioritize features. Here, after using these feedbacks, they change the software and it again these circles goes round. That is this is this developing in a circle. It is not ending, and that is called agile methods. This is earlier there were no agile methods. Start the software and end. But later, all the most of the software companies realized that that is not they can't stop those software development in for a software, but it develop continuous. It should develop continuously. So agile methods came. Toolbox for deployment. Earlier, there's a batch file that has been some modules combined in the file called batch. That's all the file needed to compile included in the batch or cmd.cmd file extension. Then run this one batch file and all when it run batch file, all others necessary file will be executed. Script language also packaging tools. There are packaging tools to automatically deployment to create uh, software development facility, deployment facility uh, include these packaging tools. Here also virtualization. Virtualization is virtual environments. That means each individual using the software may need some special environment from one person may be different from one person to another person, because when let's see consider uh, uh, Microsoft Word. Word, some may need text uh, text type, uh, uh, what is called one type, because uh, Times New Roman. One may need uh, text type, one Times New Roman. Another may need another type. So that is virtual. Individual likes, uh, it will create uh, virtual environments for suitable to the each person. That is called virtualization. Disk image is sorry. Disk image is complete package installed and then copied into the some other directly copied into the some other disk, that is disk image. Then the next topic is software security. Software security, when installed, after installing and implementing the software, each person will uh, use it. When using, sometimes uh, virus may attack to the software. So it will be a headache for the software users. Sometimes data may be erased. Sometimes software may not work. So to protect uh, the software from the attacks, we need software security. Uh, threats to the software is uh, potential damage caused by the intruders. Some outside person will damage the software. There are four types of threats. The possibility, that is possibility of attack in the to the software. Interception, interruption, modification, fabrication. These are the four types of threats. Interception. Interception is accessing software by unauthorized person programs. So accessing by tapping the communication network and obtaining data or software copies. I will explain this using this figure. This A figure A is normal software. Software is interpreted by this circle, and this is user, real user. Software will use by the user. But the interception is software is used by the user. That's okay. But a hacker, another person, unauthorized another person also can access. That is, this software is tapped by this hacker and use it. Another one is interruption. Unavailability or blocking the access of the software to authorized persons or programs. It is block because a user cannot access. It will block by the hacker. Deleting of program or data or malfunction of file manager of an operating system. Interruption. This C is interruption. User cannot access the software because maybe software is deleted or modification. Hacker modifies the software and send it to the authorized user. Because in the modification, user cannot access the real software because software is changed and with different answers will be given to the user. The program may be changed to freeze the system at a point when the condition is met. For example, the system will stop when the date becomes January 1. It will stop when the January 1 or in one day. That is one type of modification. Here you can see the modification. Software is here. Hacker change the software and user can see this modified software. Application Intruder inserts false transaction to the software. Example, a bank worker can write to the bank software to truncate fractional interests of all the accounts and save the other part to the another bank account. That is intruder change the software, but a user cannot see the changes. User can see the software and but correctly, but there is another something unwanted things happened within the software. This is fabrication. Fabrication is software. It's okay. Software is user can see the software clearly, but hidden inside the software, the hacker will do something, but can't see any user cannot see the different. This is goals of the securities. Confidential is some unwanted don't give access to the unwanted persons. Integrity is authorized users are available. Those authorized users can see that is transparency. All the users should get same answers for same questions. Availability is user also, suppose worker use software in the say, shop. This user can access within the working period. Without work, other than outside the working period, he cannot access. That is the availability. Controls to protect software from threats when data and software, because there are two sides. When data and software stored in computers, data can be changed. When transmitting data and program codes from one place to another place, that is another weak point to another possibility to access intruders or hackers. Encryption is when transmitting data, the best way to transmit to avoid hacking, encryption. Encryption is change the software code in a different format. There are two types of encryption methods, symmetric and asymmetric. Symmetric is key is used to change the source code. One key is like 3 or say 3 is used for the key. Both the sender and the receiver use same key in the symmetric encryption. Asymmetric encryption, they use different different keys. That is, you just think about symmetric and encryption. Symmetric. No need to go to the deep for this course. If you want to learn in the upper level, you will be understand. You can learn those what are those, how they implement symmetric and asymmetric encryption. Uh, Security of programs. Weaker points. Most of the time, software will be accessed by hackers using the weaker points of the software. Most of the time, hacker try to identify weaker points of the software, and then uh, they attack to these weak points. Weaker points can be created at design time, compile time, runtime. Design time is when the software design. Compile time is after designing the software should be uh, developed as a to for the compiling in the computer. That time is called compile time. Is from installing and before the run time. Before the runtime is the time user can access and using time of the software. There are two types of errors: non-malicious and malicious codes. Malicious codes are uh, uh, they change the program purposely. The virus, Trojan horse, logic bomb, trapdoor, worm, rabbit, all those things are malicious codes because these codes are included. These program codes included purposely by the intruder or hacker. Non-malicious codes are uh, not actually no one want to include, but sometimes uh, they have when design time and runtime it errors may be occurred automatically or that is okay, when designing carelessly, those non-malicious code can be included. Controls to avoid threats to the program. These controls easily can be in design time. Designers can implement uh, security by using these object-oriented methods. Modularity, encapsulation, and information hiding. This information hiding and encapsulation and also the modularity can be implemented by using the object-oriented methods. Modularity is this software is divided into manageable small pieces and uh, run it separately and check it, test it, and implement it. These separate modules are integrated in. That is called the modularity. Encapsulation is data and the methods are uh, uh, separated in the object. So program can be verified, traced and errors without affecting the other entities. The main advantage of function-oriented methods is uh, uh, if one function is changed, that will be affect to the function or other programs and other modules also. But here, when we change in encapsulation, if we design programs encapsulation, uh, data and methods are inside the object, uh, inside the class. So we can change it within the class, but not no need to change other codes. That is called encapsulation. Information hiding also can be implemented using encapsulation. Testing, I think Professor Udita described earlier, testing, unit test, integration test, function test, performance test, acceptances, all the testing methods uh, needed to implement the security method. Weaker points also can be avoided using these tested. Uh, Protecting the operating system. That is, in operating system uh, should be separated from the other other application programs and data in memory. So that is operating system should be protected by other programs. Other thing is database security. Major problems of database concerning security are data integrity. Data integrity is one data should be available in only in one place. So suppose name. If the name is saved in different places, if we want to change some data or something in the name, we have to change if there are two places. Uh, uh, if this data available in two places, we have to change in two places. If there is a, if the data is available in only in one place, we have to change it only in that place. That is called data integrity. One data is available should be available in only in one place. Most of the time, in relational databases, it try to implement this one data in one place, but sometimes it cannot do. But most of the time, it can do. Access control is different users can access in different data. That is the access control. Because if you consider the university, uh, academic can access uh, in different places, in different data. Finance can access different data like that. Thank you. Are there any questions?
Thank you, sir.
Okay.